Among the billions of stars in the Milky Way, one lies closer to Earth than any other beyond our Sun. That star is Proxima Centauri. Located just 4.24 light-years away, Proxima Centauri is our nearest stellar neighbor. But despite being the closest star system to Earth, the distance is still almost impossible to comprehend. The light reaching us from Proxima tonight began its journey more than 4 years ago, traveling across interstellar space at nearly 300,000 kilometers per second. And yet, this faint red star has become one of the most important objects in modern astronomy. Because orbiting it is a rocky planet known as Proxima Centauri b, a world that may exist inside the star's habitable zone. For the first time, the nearest star beyond our solar system appears to contain a planet that may share some similarities with Earth. For centuries, the stars were viewed as permanently unreachable. The Moon eventually became a destination. Mars became a realistic, long-term objective. But the stars remained beyond the limits of human exploration. That perception began to change when astronomers started studying Proxima Centauri more closely. What they discovered transformed this nearby star from a scientific curiosity into one of the most important planetary systems ever observed. Proxima Centauri itself is very different from the Sun. It belongs to a category called red dwarfs, the smallest and most common stars in the Milky Way galaxy. Its mass is only about 12% of the Sun's mass, and its diameter is roughly 1/7 as wide. It also produces only a small fraction of the Sun's energy, making it extremely dim compared to ordinary stars. In fact, despite being the closest neighboring star, Proxima cannot be seen with the naked eye from Earth. But stars like this dominate the galaxy. Nearly 70% of all stars in the Milky Way are red dwarfs. That means understanding systems like Proxima could help scientists understand how common potentially habitable planets may be throughout the universe. For many years, however, astronomers questioned whether planets around red dwarfs could support life at all. The reason is instability. Unlike the Sun, which remains relatively calm most of the time, Proxima Centauri is highly active. Deep inside the star, hot plasma moves constantly, generating unstable magnetic fields. When those magnetic fields suddenly reconnect, the star releases powerful stellar flares. These eruptions send bursts of radiation into surrounding space, including X-rays and ultraviolet energy. And because planets around red dwarfs must orbit extremely close to receive enough warmth, they are exposed to those eruptions at short range. That created one of the biggest questions surrounding the Proxima system. Could a planet survive in such an environment? In 2016, astronomers announced a discovery that immediately changed the discussion. Using years of observations, scientists detected evidence of a rocky planet orbiting Proxima Centauri. The discovery attracted worldwide attention because the planet appeared to orbit inside the habitable zone, the region around a star where temperatures may allow liquid water to exist on a planet's surface. In astronomy, liquid water is one of the most important conditions scientists search for when studying potentially habitable worlds. Where stable water exists, chemistry becomes more complex. And where chemistry becomes more complex, the possibility of life begins to emerge. At first glance, Proxima b appeared promising. The planet is only slightly more massive than Earth, suggesting it may have a rocky surface rather than a thick gaseous atmosphere like Neptune or Jupiter. But conditions there are very different from those on Earth. Earth orbits the Sun at a distance of around 150 million kilometers and completes one orbit every 365 days. Proxima b, by contrast, orbits only about 7 million kilometers from its parent star. That means its entire orbit could fit well inside Mercury's orbit around the Sun. As a result, one full year on Proxima b lasts only about 11 Earth days. The planet must remain that close because Proxima Centauri produces far less heat and light than the Sun. If the planet orbited farther away, temperatures would likely become too cold for liquid water to survive. But being close to the star creates serious risks. Observations show that Proxima Centauri can produce violent flares capable of dramatically increasing radiation levels across the system. Some eruptions may be far stronger than anything recorded from our own Sun in modern history. On Earth, life is protected by two major defenses. The atmosphere absorbs much of the harmful radiation coming from space, while Earth's magnetic field deflects charged particles before they can reach the surface. Scientists still do not know whether Proxima b possesses either of those protections. If the planet lacks a strong magnetic field, radiation from the star could gradually strip away its atmosphere over millions of years. Without an atmosphere, surface water could disappear, leaving behind a dry and hostile world. Another major possibility is tidal locking. Because Proxima b orbits so close to its star, gravity may have synchronized the planet's rotation. If that has happened, one side of the planet permanently faces the star, while the opposite side remains in constant darkness. This is similar to how the same side of the Moon always faces Earth. If Proxima b is tidally locked, the planet may be divided into two extreme hemispheres. The side facing the star would experience continuous daylight and constant radiation exposure. Temperatures there could become extremely high depending on atmospheric conditions. Meanwhile, the opposite side could remain permanently frozen beneath endless darkness. However, scientists believe there may be a more stable region between those extremes, a narrow band where heat from the star is balanced by cooling from the dark side. If the planet has a sufficiently thick atmosphere, winds could transport heat around the world, preventing temperatures from becoming too extreme. That could create a permanent zone where liquid water might remain stable. If life exists there, it would evolve under conditions completely different from those on Earth. There would be no ordinary sunrise or sunset, no normal day-night cycle, no familiar seasons. Any ecosystem would adapt to a world where environmental conditions remain largely constant over time. Plants, if they exist, might evolve to absorb the faint reddish light produced by the star. At the moment, however, much about Proxima b remains uncertain. Scientists still cannot directly observe its surface. Many of the planet's characteristics are based on indirect measurements and computer simulations. Future telescopes may eventually determine whether the planet possesses an atmosphere, whether water exists there, or whether conditions are too hostile for life to survive. But even if Proxima b turned out to be habitable, another challenge remains: reaching it. The distance between stars represents one of the greatest barriers humanity has ever faced. The Moon is about 300 to 84,000 kilometers away. Mars can be tens of millions of kilometers from Earth, depending on orbital positions. Proxima Centauri is nearly 40 trillion kilometers away. That scale changes everything. The farthest human-made object ever launched is Voyager 1. Since its launch in 1977, Voyager 1 has traveled beyond the outer boundary of the solar system and entered interstellar space. Even after nearly 50 years of continuous travel, it has covered only a tiny fraction of the distance to Proxima Centauri. At its current speed, Voyager would require more than 70,000 years to arrive. That means interstellar travel cannot rely on slightly improved versions of today's spacecraft. Entirely new propulsion systems would be necessary. Some concepts involve nuclear propulsion, while others explore fusion engines or antimatter-based technology. One of the most widely discussed projects is Breakthrough Starshot. The idea proposes using powerful Earth-based lasers to accelerate tiny robotic probes equipped with ultralight sails. Instead of carrying large fuel reserves, the probes would be pushed forward by concentrated laser energy. If successful, they could potentially reach speeds approaching 20% of the speed of light. At that velocity, a spacecraft could travel to Proxima Centauri in roughly 20 years. For the first time, another star system begins to appear technologically reachable within a human lifetime. But traveling at those speeds introduces entirely new dangers. Interstellar space may appear empty, but it still contains scattered particles and microscopic dust grains. At ordinary spacecraft speeds, those particles are harmless. At relativistic speeds, even a tiny grain of dust could strike with enormous energy, potentially damaging or destroying a spacecraft. Radiation also becomes a major problem. A crewed mission lasting decades would expose astronauts to deep space radiation continuously for years. Outside Earth's magnetic field, there is little natural protection. Long-term exposure could damage DNA, weaken organs, and increase cancer risks significantly. And unlike missions within the solar system, there would be no rescue mission and no quick return home. Because of those challenges, many scientists believe the first mission to another star system will likely be robotic rather than human. Small autonomous probes may reach Proxima long before astronauts ever do. Even a brief flyby could transform our understanding of the universe. The first close images of another planetary system. The first direct measurements of an Earth-sized planet orbiting another star. Possibly even the first evidence of biological activity beyond Earth. For now, Proxima Centauri remains a faint red point hidden in the southern sky. A nearby star separated from Earth by more than 4 years of travel at the speed of light. Yet despite that distance, it has already changed astronomy. Because for the first time, humanity is no longer discussing hypothetical Earth-like planets located hundreds of light years away. The nearest star itself may already contain one. And that possibility has turned Proxima Centauri into more than just another object in space.